In this video lesson, we are going to look at addition and subtraction of algebraic fractions. So before we start with the actual sums, I just want to recap on what you do basically when you have to add two fractions and what you do when you have to multiply two fractions. And just to clear out the confusion between the two and the steps that are involved. Okay, so when you add two fractions or subtract, you have to always think about lowest common denominator first. Okay, that's always, you can't add two fractions if the denominators aren't the same. Right, and in this case, our lowest common denominator will be BD because it has to be something that contains each and every factor that has, so it's the lowest common denominator or the lowest common factor. Right, so then we have to change this to BD. So in order to do that, we have to multiply this one with D. All right, and what we do at the bottom, we have to do at the top. So this one also gets multiplied with D. And in this case, we need B. So we multiply with B, but we do that at the top as well. Okay, then we can see, okay, we've got AD over BD plus CB over BD. Okay, now that our denominators are the same, now only we can add the numerators. So AD plus CB over BD. Okay, so that's just the general form for what you're going to do when you have to simplify these fractions. Now, when we multiply two fractions, that is far easier, but we'll look at that in more detail in the next lesson on multiplication of fractions. But just to give you a basic, now obviously you can cancel if there's something you can cancel, but basically all you need to do is you multiply the numerators together, so that's going to be AC, and you multiply the denominators together, so that gives you BD, and that's it. Okay, now here's a couple of things that I also want to bring to your attention that I've seen is quite a bit of common mistakes that I've seen. And the first one is when you have something like 1 plus x over x, this x and this x cannot cancel each other because of this plus over here. This is two terms, 1 plus x, this is two terms. You can't cancel something that has two terms over one term. It has to be one term over one term. So in this case, this is the final answer. If it ends like that, that's the answer. But what you would do, for example, here we won't cancel the x, of course, but here we can factor out an x first. So we'll take out an x, and then we're left with x plus 1. Now you'll see that this actually is one term, okay, because this x is a factor, x plus 1 is a factor. So now you can actually cancel this x with this x, and then you have x plus 1 left. Okay, and then a final thing is if I have a minus b, it's not the same as b minus a. So for example, let's say I have 5 minus 2, that gives me 3. But if I have 2 minus 5, that gives me negative 3. So these aren't the same. Although if you have a plus b and b plus a, that is the same, because 5 plus 2 gives you 7 and 2 plus 5 is 7. So that's the same. But in the case when we have a negative, what do we do to change it to look like the one on top? So I start with b minus a. Now when I rearrange terms, remember it's important that the sign in front of the term is its tail. It follows it. So if I put the a first, I write minus a plus b, because this one has this is a negative a. See, like this value, this is a positive 3, that's a negative 3. If I'm going to move it, I can't change its sign. Okay, so now it's still not looking like that one, but we can take out a negative. So if I take out a negative, the a changes sign, the b changes sign, then we have a minus b. All right, so that's basically what happens, or how we can get it to that. But that's not what we're always going to do, because, well, that's what we're going to do, but we're not going to do it in so many steps. Because this is going to take a lot of time. So all that we can do, or that we have to do, need to do, is to remember that if you change if you swap two terms around and there's a negative between them, all you do is you change the sign in front of the bracket or the factor, and then, or the fraction, and then you can change them around. So in this case, what we do is this is represented by plus, so it's going to become minus, right, a minus b over a minus b. So I have changed the sign in front of the fraction, and I have swapped around these two terms. Okay, so now we are at the type of sums that we can expect in the tests and exams. Now, the algebraic fractions, addition and subtraction, there are basic steps that you normally follow. For all of them, they're basically the same. You just follow those steps and you'll get to your final answer. So, like we've seen earlier, like the first thing you do when you have to add two fractions, you have to get the lowest common denominator. So find the lowest common denominator and set all terms over the lowest common denominator. So this represents one factor, that represents one factor. And therefore, our lowest common denominator, something that contains something of everything, or a factor, or the type of factors that there are. This is x plus 2 and x minus 2. That is our lowest common denominator. So to put the first term over the lowest common denominator, what do we need? We need a x minus 2, alright? But what I do at the bottom, I have to do at the top, so I'm going to also multiply this with x minus 2. And then this one gets multiplied with x plus 2, because it needs an x plus 2, and then at the top also x plus 2. Okay, so then after I have done that, I am going to write the expression over one long dividing line. So 2 multiplied by x minus 2 plus 3 multiplied by x plus 2. And that's all over x plus 2, x minus 2. Right, so notice now that I haven't multiplied it out yet. Now, most of the people, most of students I've seen does that directly. In this case, it wouldn't have mattered really, but in most cases, some cases there's a minus over there, and in most cases I've seen that if you multiply it out directly, you tend to forget the minus there. So they would multiply out the 3, but they would not multiply in the negative, and that's where a very common mistake happens. So for me, in general, I would just leave it as this first, and then use the next step to multiply out my bracket. So this becomes 2x minus 4 plus 3x plus 6 all over x plus 2 and x minus 2. Okay, so notice that I'm not multiplying out the denominator because we keep that in factored form, because sometimes the sum would simplify in the numerator, and then you'd be able to actually cancel it furthermore after you've simplified the numerator. So this becomes 5x plus 2 all over x plus 2 and x minus 2. Okay, so that is then the final answer, because it can't cancel or simplify any further. Okay, so those are the 4 steps then. We multiplied out the numerator, and then we simplified the expression. Okay, so let's run through one last example on following through on those steps. In this case, we can see we've got a minus 1, a minus 2, and a 1 minus a. Alright, so we can change this 1 minus a into a minus 1, like we've seen previously. If you don't, then this 1 minus a need to be part of your lowest common denominator, which would make your calculations a lot longer. So it's definitely good to first change it. So we've got a plus 2 over a minus 1 plus 3 over a minus 2, and then I'm going to change the sign to a plus and then swap these two around, a minus 1. Okay, now our lowest common denominator will be a minus 1 and a minus 2. Right, this one needs a minus 2. So I'm going to multiply that top and bottom. And then this one would need a minus 1 top and bottom. And this one would need a minus 2 top and bottom. Okay, so now I'm just going to write that out. So I've got we've got a plus 2 and a minus 2, and then plus 3, a minus 1 plus 2, a minus 2. So that's all over a minus 1 and a minus 2. Alright, multiplying it out. Now we can FOIL this out, but that is going to be a longer way than necessary, because we can see that these factors a plus 2 and a minus 2, they are the factored form of a squared minus 4, which is difference of squares. So if you know that or recognize that, you can just write a squared minus 4, and then we multiply those out. So plus 3a minus 3, and then plus 2a minus 4, all over a minus 1 and a minus 2. Okay, then simplifying, a squared plus 5a minus 11. If we add all the like terms. Okay, now many times, especially if you end up with a trinomial, it might happen that the trinomial can actually factorize, and then it might be able to cancel with one of these factors here, but in this case this trinomial can't factorize, so this would then simply be our final answer.